Yeah, glad to be here and then talk about what blockchain is all about. So, um, how could I interact with students? I don't see anyone.
So what we'll do is we will so the students can enter their questions on the YouTube chat, and I'll just let you know what the questions are. So if you need any interaction with the students, you can just let me know and I'll keep a tab on the comment section. So students, in case of any questions, any queries that you have, and to make this more interactive, or whatever question is asked by Mr. Kiran, just make sure you enter those responses in the YouTube chat section, and I'll keep Mr. Kiran updated about the same. So let's start then.
Yeah, cool. Thank you. Yeah, just to give a brief intro about me, I'm the co-founder of Web3 Learn. We are a blockchain skilling platform. So primarily focusing on tech and non-tech parts. We train people on getting into blockchain through Solidity, which is one of the programming language. And also we've been focusing a lot on non-tech aspects, something like gaming, how to become an effective community manager, and then also there are a bunch of non-tech related stuff like UI, UX design, project management, and product management. So we teach folks exclusively on how to get into these sectors and areas within the blockchain space. So on that note, let me share my screen and then I'm happy to walk through what this will be a mix of uh, this will be a mix of the content that we have prepared, and at the same time I want to actually show a real demo of like what a block is all about, how do you, what a hash is all about, etc. So that you understand and you can play around once you go back. You can play around with different hash nodes and what get a deep level understanding of what blockchain is all about. um, so deep diving into like what I'd like to start with a subtle difference, or there are major differences between what a Web 2 and Web 3 is all about. So primarily, if you see, before even going into the Web 2, let me actually go to Web 1. So might be that would be the good starting point for us. Um, so Web 1, which got started in 1990s. Where what used to happen those days in 1990s is you used to have only a static page or a static website. So if you are a user of internet, you have to log in. There is no login option as well, by the way. You just have to type in whatever www, and then that opens a particular page, and then you can go to that particular page and start reading content. So what I'm trying to say there is you were not able to create an account there, or you were not able to interact with that particular content. It's just the static information that you are supposed to consume. So that was like Web 1, which was in 1990s to early 2000s. And then the era of Web 2 have come into the picture, where we said, why do we have to just only read the content that is there on the particular website? Might be we should interact with the content and we should have the ability to change the content there, right? So then Web 2 came into the picture, where the present era is all about Web 2. I'm sure most of you might have had like Facebook accounts, Instagram, Snapchat accounts, etc. and all. So what you generally do is you create an account, and you log in into your account. There is this website, right? There is a Facebook website. But like on the top of it, you create a user login, which is your information. You get into that particular website and you interact with various elements within the website, right? So you can actually text to your friend, like you can add your friend, like you can comment on your friends, you can like, favorite, whatnot, right? You can share. There is like bunch of activities that you could do. That is read and write. That we are in the present era. Whatever era that we are is in the Web 2 era, with regards to the internet technologies. Now the problem here in the Web 2 era is you as a user are creating the profile and then you are interacting on a particular website, right? Say something like Facebook and Instagram. Now go back and then think of the question, who owns my data, right? So I'm putting in my name, I'm giving my email ID, I'm giving my phone number, etc. and all. At the end of the day, those companies are actually owning the data. Google is owning your data, Facebook is owning your data, Instagram is owning your data, and they're actually using your data, to sell it to advertisement agencies, to the brands, to anyone who are looking to put ads and show relevant ads or irrelevant ads, to you, right? So primarily what they're doing is they're actually using your data and they're making money on top of it. But the unfortunate situation is you are not making any money, right? So you are just giving the data for free to them and you are not getting benefited out of the data and out of all the interactions that you're doing on a particular website. Now enter into Web3. That is where we will the Web3 technology is looking to disrupt and change, and the whole blockchain concept has come into picture. Going back to the previous point of, now there is a website, there is a Facebook website. Now you will be in the web in the future Web3 era, you will be creating your profile, which is similar to what you will be doing now. But whereas, with regards to the data, the main subtle difference there is the data will not be owned by Facebook or Google or Instagram. Rather, the data will be owned by us. When I mean by us, it's the users, right? So if you're a group of like 10 students, right? And comparing that to the blockchain, I'll show that in a bit, so that you understand more about like how it works. But say if you're a group of 10 friends and then like you wanted to own the data of your own, it is quite possible, in the blockchain scene. So primarily, like it is all about decentralization. So there is not going to be any centralized agencies or institutions like Facebooks and Googles and Instagrams of the world. Rather, you will be owning your own data. That is the main subtle difference that is going to happen in the Web3 world. And what is going to happen there is you can own your data, and at the same time, for you, if you are spending say 5 hours or 8 hours on internet each and every day, you should be able to make money on top of it, which is the beauty, that is shaping up in the Web3 world. Like if there are any questions, I'm happy to talk about this particular use cases. So that's what I've been referring to in these two slides. The Instagram, Facebook, LinkedIn is Web2, and then Web3 is the so-called new age internet, where you own the data instead of the tech giants making money out of you. Okay. So on that note, let me transition into what a blockchain is all about, and then actually show you. I actually wanted to show one particular YouTube video. Just give me a second. I hope I can show you this. Are you getting the volume of the video?
You can start playing it again, and the volume is not coming.
Just give me one second.
You can stop sharing and try sharing again, then it will, the multimedia will come. Yeah. Milan, there's one question. Do we have any examples for Web3 implementation?
Yeah, I'll come to that.
Okay.
Since he could
Can you hear this now?
Yeah.
Jacob always.
Okay. So just to set the context here, what I want to do is, just understand this. This is a very simple, day-to-day use case that you guys might be facing this, right? Let me play this for you.
Let me tell you a short story about a little fellow called Jacob. Since he could remember, Jacob always wanted to get a blue cat, but his parents were always finding ways to not get it for him. So, one Christmas, he figured out a way to finally get his dream pet. He would send his wish to Santa. Oh, how excited he was when he wrote the letter. But Jacob was too young to take the letter to the post office by himself, so the next morning, he had to ask his dad to do it for him. You could say that his dad was the middleman between Jacob and Santa. He never imagined that on his way to the post office, his dad would open the letter, read it, and replace the blue cat on the list with a brand new pair of socks. The letter was posted to the North Pole, to Santa and the elves. When they received it, they started working right away, making Jacob's gift. So that year, Jacob received an adorable pair of socks. But next Christmas, Jacob decided to use the blockchain. Jacob wrote exactly the same letter, but instead of giving it to his mum or dad to deliver, he directly uploaded it to the North Pole blockchain. The North Pole blockchain is made up of a lot of computers connected to one another through the internet that all store a copy of everyone's Christmas list. The network is being monitored at the same time by all the elves, Santa himself, and even people like Jacob's parents. Every time a new letter is received, it is saved onto every individual computer, so everyone has the exact same copy. As the blockchain is an open network, everyone can see all the letters, even though it's impossible to know to whom each one belongs to. But when Jacob's parents saw that there was a letter asking for a blue cat, it wasn't hard for them to know that it was from Jacob. So, once again, they changed it, this time for a cookbook. But as every other node had a copy of Jacob's real letter, the change was spotted, and the computer trying to make the change was cut off from the network, meaning Jacob's real letter remained unchanged. So, guess what Jacob received that year for Christmas?
Okay, cool. So the reason why I actually showed you guys this video is let's actually deep dive and then see how exactly that happened, right? So apart from the data thing that I was talking about before, where your data is being owned by these big institutions, there is also the problem with the intermediaries, right? In terms of now in this example now, Jacob wants something, but like dad doesn't want him to have a cat, so he changed it and like he put in socks, there. Now, the best part of the blockchain is once you actually put any information on the blockchain, no one can actually erase it. And if someone wants to erase it and then wants to change the data, it becomes very difficult. We'll actually go through one very simple example. I'll show you that how. But primarily what I'm leading towards to and then wanted to show you is this concept of immutability, right? What immutable is, if I'm writing a letter to you and like praising your glory, and giving you a certification, and if I'm putting that on the blockchain, that's it, right? So that certification, I cannot even go back and then change that certification. Even if like in the near future, like I don't like you, I say, okay, hey, what is this all about? Let me go back and change my certification, or like the praise that I've given you. I cannot change it because I have put the entire certification on the blockchain. Okay, so let me not waste much of the time. I wanted to actually quickly show you. So might be, I think I put it in the content, but like if that is not the case, jot on this, take a note of this particular website. If you wanted to start playing with me when I'm showing you this, please feel free to do so. So here, the first concept that I wanted to just show you guys, so all those content and video are there in the material. Feel free to watch the videos as many times as possible. So what I wanted to show you here is what exactly a hash is all about is we can input the data in any format. Okay, so it could be a 50 character, 100 character, 500 character, or 1,000 character. Uh, Whatever could be the data format or whatever could be the data length. Eventually, we will be getting a constant length of 256 characters because I'm using a specific program, not a program, a uh, specific type of hash called SHA-256, which is what you see here, right? So it's like 256 characters in length, primarily. And let's not go deep into like what exactly happens. This is the concept behind the cryptography, um, which is the core component of a blockchain. Um, before even going into that, I wanted to show you this part, which is the first paper of the Bitcoin, the Satoshi Nakamoto wrote. First of all, what a blockchain and a Bitcoin is all about. Again, feel free to explore and read that as many times as possible. You might not get it in one go, two goes, but this is the heart and core of whatever is happening in the blockchain at the moment. Okay, so let's transform this into real example. So I wanted to show you guys how the data is changing, how these unique characters are changing each and every time, right? So for example, if I put in ATL Tinkering Lab, right? I want you to observe here how things are changing. Okay, so here ATL Tinkering Lab, everything is in caps, and I'm getting this unique hash each and every time whenever I'm typing something, right? Wishes you great success. And
So, Kiran, there is a slight lag, so you might have to slow down, whenever you are changing the string so that we can see the difference in the hash.
okay. Yeah, the hash changes very quickly, to be frank. Okay, let me type in one by one. Does it help?
Yeah, better now.
Okay. So primarily what I have done is, I put in this ATL tinkering, but we will put in lab here, wishes you success in all your endeavors, right? So let me just copy this, and I wanted to show you a couple of things here. Okay. So imagine when I put in the ATL Tinkering Lab wishes you success in all your endeavors. Um, just observe what is the hash number starting with, right? It is 845 F91, right? So let's actually copy down these 845 F91. Okay. You guys are there with me, right? So this is how things are going to change in a blockchain, right? And blockchain is actually driven by hash, which we will learn in the next steps. So this is the basic, okay, of how the unique hashes are generated each and every time. So let me actually change a couple of stuff here, okay? So I want to change the T to small t, okay? I'll change the L to capital L, okay? S to small s, okay? And then E to capital E, okay? So now what has happened? So let's compare these two, okay? Now, if you see the hash here, right? The hash has changed to like what? F7B8C, okay? F7B8C is a different hash that we were able to generate just because we were able to change from small cap to large cap and large cap to small cap, okay? So this is how you actually generate unique hash, for a unique input. So this is a unique, input here in this instance. The previous one was a other unique input. So based on the input, like you will be, getting a unique output, which is nothing but the hash here in the blockchain space. So as I said, don't worry too much about how this is getting transformed. This is all part of the cryptography which is happening in the backend. Okay. Now, the interesting thing that I wanted to show you is if I go back to this ATL Tinkering Lab wishes you success in all your endeavors, to our previous example there. So now what is the hash here? F7B8C, right? So go back and then type this one here. Um, okay. So this is exactly what I wanted to show you. So if I put in the same information before, how many times you input it, right? Now you go back and observe the hash here, So what is the hash here again, starting with 845F91. So it's the same hash that we got even in the previous mode as well, right? So the point that I'm trying to emphasize and make here is, for a unique input, okay, you are going to get a unique output and hash there. But how many times, you input, okay, like even if you, okay, let me take a step back. So that input, right, as long as you're not actually, if you're changing it, you're going to get in different hash. But as long as the input is same, right, in this case, the input is same. You input this today, or you input this tomorrow, or you input this even 10 days later, you are going to get the same hash. You're getting my point, right? So there is going to be unique, hash that will be generated on the blockchain for a unique input, and that is, that is going to be forever, that is going to be permanent, that is going to be immutable. Are you guys getting my point, right? So, like, if anyone wants to, change the hash, they have to change something here. If I change this to the capital Y, again the hash changes there. So then you can see that, okay, hey, for that particular input, there is this 84591 hash. I'm getting a different hash. That means something has changed in the input. So you can actually derive that like someone has actually tampered with your blockchain. Make sense? Or is it too complicated at the moment? It's a very simple concept, There is a hash, you give the input and like you get a unique output. Okay. Now let's build on top of this, right? Now, what I was mentioning was, so if you see here, there is a block, there is a nonce, there is a data, there is a hash. Okay. So again, don't get confused with all these topics. You will be learning that, like, as you study and as you go along. Just understand this, here, what is happened here is the green screen indicates, there is a particular block, that is actually verified, per se. Let me actually simplify this a little further, so going back to our YouTube example, right? So what happened in the YouTube example? Now, Jacob has written the, that he wants a cat, and there are 10 computers, across the network. The 10 computers are called blocks, right? Each computer is called a block by that. Okay. So there are 10 computers within the blockchain, for simplicity's sake. And this letter is going and sitting in all the 10 computers at the same time. Okay. That is in the block. If someone is changing some input, in that letter, everyone will be notified that there is going to be a change. And if people can decide whether to accept that change or whether to reject that change. Okay. So hope that is clear. Hope I'm not complicating. So going back to this point, right? So coming to this block part, right? So this block is imagined now, a verified blockchain, right? So Jacob has sent the cat to this blockchain, and we have, we have verified that, okay, there is a letter here. Okay. Now, what happens if I change some data, in the blockchain, right? So imagine if I start putting in some data here, right? So there is test. You see the change in the color that is happening here. Test 1, 2, 3, 4, 5, 6. Hi, hello, etc. Welcome, etc. And all that stuff, right? So that means I'm actually making some changes to the existing block there. Okay. Now, if I have to be the part of the blockchain, I need to actually be verified. I need to verify my block further, right? So what I need to do is, I need to click on this mine button here. So this is something, the computing power that is happening in the blockchain. So, okay, I wanted to show you this before going back. Hold on, show you. Okay. So this is the initial thing, right? Just observe. I wanted you guys to observe this hash. The hash starts with 4 zeros here initially, right? Now I'm changing this. The block there. The data I'm changing. Now, what is happening with the hash here? So 95AB601, some hash number is getting changed there. Okay. So for me to go 0000 is the validation of the block. Okay. So for that, I need to actually click on mine, and so that you see here what is happening. So even though I'm inputting the data here, after mining, that is like, after spending some computation power, my block is getting verified in that particular blockchain. Make sense? Okay. So let's quickly move on, build on to, this part, there might be, you will understand a little bit. So now let's go to what blockchain is all about, right? Or yeah, I think let me show you this part. You will understand this a little better. Now, in this case, what I want you to guys to do is go back to our previous example of Jacob, right? So what happened? What did Jacob say here? So he has sent it to
But as
the
every other node,
blockchain. So there are different computers here, right? But like his dad tried changing something here, and what has happened was, it was rejected by other people here. Okay. Now I wanted to show you exactly how it happens. So for example, now there is this block 1, block 2, block 3, block 4, and block 5. Okay. So this is where imagine now that Jacob has sent the letter to our blockchain. Okay, imagine now this is the blockchain, right? So there are 5 blocks. Imagine this 5 blocks as 5 different computers, going back to this previous example. Okay. Now what I wanted to do is, I actually wanted to show you if I make changes here, okay, what is going to happen in the blockchain. But before even going to that, right, I wanted you guys to observe on how this interconnectivity in the blockchain is happening. So just pay some attention here, right? So the hash here is 000 and it starts with 1578. Okay, so this is, imagine like the first computer in the blockchain. Okay, now go back to the second computer or the second computer in the blockchain. Now, so this, since it's the first computer, it is all, the previous is all zeros, by the way, right? So now the second computer is interlinked to the first computer using the hash of this first computer. If you see here, it's 0001578 3B. You guys are getting it, right? Now, we will be doing some set of transactions, and this block has a unique hash here. The block of this particular, sorry, the hash of this particular block is 00012FA90. Okay. Now go back to block 3, which is like computer 3, right? So now what is happening here? So the previous, is interlinked to the hash of the block 2, which is 00012FA9. Okay. And then you do something here, and then you get like, some unique hash here for, the computer 3. So similarly on that, right? So what I'm trying to say here is, so all these computers are interlinked. Okay. So we will see like, how difficult it becomes to change things on blockchain. And like, how you can actually reject some of the data. But going back to my previous point, guys, if I say, what did I say? I said like, the data will be owned by you guys. The data is not owned by the platforms. Okay. So what I'm trying to show here is, this is how the data is owned by, you guys. That means in the Web3 world, by using different nodes. Nodes are nothing but different computers across the world, right? Rather than, there is a server sitting in, California, there is a Facebook server where all your data is staying there. In the Web3 world, there are going to be different computers, different distributed systems across the globe, where your data will be stored, might be, on the same computer in Nigeria, in India, in Singapore. Of course, those are all secure data, there is a cryptography behind that. So it is actually spread across the globe, okay? So let's go back and do some fun exercise here, right? So this is a clear, clean blockchain. Now let's try to disrupt the blockchain here. Okay, let me start disrupting the blockchain. Where? Okay, on 4, right? I just wanted to show you here. So if I start disrupting the blockchain here, right? So if we see test 1, 2, 3, 4, okay. Now what is happening here? So these 5 blocks are connected in the blockchain, right? The block 1 is green, block 2 is green, block 3 is green, right? That means we are not touching the data, or we are not disrupting the data on those blocks. So it's like the data is flowing from 1 to 2 to 3 to 4 to 5, okay? I'm actually disrupting the data on block 4. That means I'm disrupting the data, from here on onwards, right? From block 4, 5, 6, 7, 8, everything is getting disrupted, okay? Now, going back to my previous point of, I want you guys to observe here, even though the hash remains same here, right? 4 zeros be 901, that is fine there. But here, the hash is not the same here, okay? Let me remove this, and then I want you to guys observe what is the hash before. The hash is 4 zeros, AE8. But when I disrupt this data, what is happening? The hash is changing here, right? Now, for me to ensure, the block is in the blockchain and everything is fine. Now I need to mine the data here again, okay? So if I start mining the data, which is nothing but like a computational power to ensure that the data is accurate on the blockchain. See, it is taking time, okay? See guys, now what has happened? So it's 00088C, okay? But now observe this here, the block 4 has been corrected, right? But like having said that, block 5 is still in red, it's still not yet been corrected, okay? So here the hash is still like, B8678188A, etc. and all, okay? Now I need to go back and then click on mine here, okay? And then you see here, it's 006E7 or whatever, Now, the data is good here. Makes sense now? Any questions or any confusion there so far?
So, Kiran, we have two questions coming in from the chat sections. One is what exactly is a hash? And a follow-up is it possible to find input data from hash as well, or is only the other way around, that is from input to hash?
That's a great question. That's a very, very, very good question and a smart question. You cannot find the data using the hash information. I get what you're saying. So if I give you the hash information, can you go and find what is the data here, right? No, the reverse is not possible. Like it flows only from A to B. It cannot flow from B to A. Make sense? So this is unique thing, the cryptography, that is happening on the back end, which is the beauty of the blockchain. See, if someone was able to retrieve the information using the hash, right? I think everyone would be on that, mode to find what is the data behind it and then start tampering or, tinkering with the data. So to your question, when you have the data, you can actually convert it to a hash, but like, using the hash, you cannot actually find what the data is behind. So going back to the other question of what hash is, right? So hash is a cryptographic form of representation of the data, in a safer and secure form, okay? As I said, like, let me not go deep into the cryptography part, because it is little complex and might be not in the purview of this session. So going back to this blockchain thing, right? And so for example, like let me show you what is the advantage and benefit of a hash. So here, let me start typing very quickly, right? Okay, what am I typing here? I'm typing a bunch of stuff here, right? So what I'm trying to show here is, initially when I had like 4 to 5 to 6 words, you got a unique hash there. Okay, but like the length is same, right? Imagine the length, the hash has changed, but the length hasn't changed. The length is only 256, as per SHA 256 standards. Okay, even if I'm putting in like lot of data, I have put in like 2 lines of data here. Okay, that whole data is getting converted into a hash here for me, right? So all my data is represented by the 256 characters at the end of the day. Okay, the reason why I'm actually showing you this is, so for example, now the data has to move the like millions and millions of rows of data, or like loads of data has to move on the blockchain from one block to another block, as what we are seeing here, right? So data is moving from one block to second block to third block to fourth block. Like, so there are like hundreds and thousands of nodes, across blockchain network. Okay, imagine like kind of making the data flow, without encryption, without cryptography, and without having to, limiting, the length of the data there. Okay, how difficult and cumbersome it becomes in actually transferring the data. Okay, so what blockchain does is, whatever the length of the data you give, right, it actually, uses this concept of cryptography in the backend and will give you that unique hash, which is standard length, where you can actually use this hash to transfer the data across different blocks in the blockchain and then start executing it. Okay, so does it make sense? Are you able to get the use case here? Okay, cool. Yeah, moving on. Yeah, so here I tinkered with the 4, right? So let me actually tinker with, similarly with, the block 3. See, if I'm tinkering with block 3, 3, 4, 5, is getting disrupted. Similarly, if I'm tinkering with, block 6, sorry, block 2, everything is getting disrupted, right? So like 2, 3, 4, 5 is getting disrupted. So here, if I'm tinkering with this one, so the whole blockchain got disrupted here. Okay. So you need to correct this, and then like, you need to get onto the hash again and again and again. Okay. So yeah, what I'm suggesting is, go to this website and then start playing and watch that video that we have put forth. You will understand it, and like it's all about experimentation. When you start experimenting, like you learn. Yeah. On that note, let me segue. So this is what I have shown you guys. This is about like payment transactions. Again, that's part of the website. You can actually walk through. I'll touch, like 5 minutes on Bitcoin, Ethereum, and NFTs, and then we'll take questions there. So I'm sure like most of you know what Bitcoin is all about. These days, everyone is on internet, right? So it's the first crypto widely accepted cryptocurrency. I showed you the paper. So this is the genesis of the paper for the Bitcoin. Which talks about this cryptography, hash, nodes, networks, etc., and all that stuff. So just understand these basics of Bitcoin. Satoshi Nakamoto. So this is the guy. This is the actual paper there. Who wrote this paper? The best part and the beauty of the Bitcoin is there are only 21 million Bitcoin available. So again, not getting into the concepts of like how Bitcoin comes into picture and all, the proof of work and all that concepts there. But like there are only just know that there are only 21 million Bitcoin available. So there is only a specific demand. That is why you can see the Bitcoin price fluctuating and growing based on the demand and supply mismatch there. Features of Bitcoin, again, decentralized, immutable, open. Like we touched upon what decentralized is so far. Immutable, you cannot actually override and do the transactions. So this like the time and milestones that we mentioned. Obviously, the another part, which is an important coin, which is an important cryptocurrency at this point of time, is Ethereum. So the basic difference between Bitcoin and Ethereum is, you cannot actually build any applications on top of Bitcoin. Bitcoin is just used as only like a currency, okay. But whereas using Ethereum, there is a programming language called Solidity, under Ethereum. Using Ethereum, what you can actually do is you can actually start building applications, and you can actually start like you can literally create a Facebook in Web3 world and a decentralized world, using Ethereum. Okay. So Ether again, like has how Bitcoin is, Ether is the coin for the Ethereum there. So what is actually the gas? This is what I wanted to touch upon. So here I actually showed you this mine thing, right? So when I clicked on the mine, what has happened? See, you see the the transaction that is going on, the computational power that is happening here. Since this is a demo website, like we are not paying any money, to do mining, in the sense like to do a transaction on this particular block. Okay, so what I wanted to show you is, let me show you this, right? So test, right? So when we do the mine, the hash comes to 0000. Okay, but in the real world, okay, what you need to do is you need to start paying something called as a gas. Gas is actually nothing but a smaller piece of money that you pay for your block to perform the particular transaction. Okay, so for example, if you are running a transaction there, it might be you need to pay 0.0001 ETH, Ethereum, or 0.2 Ethereum, or 0.3 Ethereum, depending on like the value of the transaction, how soon you wanted to get the transaction done, and within that whole block, how many people are doing the transactions at the same time. Okay. So smart contract is the one, that's a concept where you can actually start learning writing smart contracts, and you can start building applications on top of Ethereum there. There's a milestones you can go through. Obviously, most of you might have heard of what an NFT is. We can go through this video and then you'll understand what an NFT is. So primarily, NFTs are digital identities. So if you create a specific art, like that art actually belongs, you can actually ensure that no one in the world can replicate that art, right? By putting it on a blockchain. Going back to your previous concept, and the example what you have seen, right, with the Jason putting the cat thing on the blockchain, no one can erase that cat thing, right? No one can erase his request. So similarly, if you are a digital artist, you can actually create digital art in the blockchain space, and you can actually put it in the blockchain so that no one can tamper around that. And what the interesting part is, you can actually start selling that. People have made millions of dollars, selling NFTs in 2021. Of course, don't experiment now. Like things are very at a very hazy phase at this point of time with whatever is happening in the market. So the reason I put is Boardgate Ape Club is one of the popular NFTs. They have only 10,000 NFTs that they have created, and last year their NFT is 0.8 Ethereum, which is around $3,000, which is like close to 210,000 rupees in the Indian rupees. And I think as of today, one NFT is actually, some NFTs are actually trading on an average of $50 million, right? So that's like close to 350 crores. So 2 lakhs to 350 crores, you can see the value of your NFT, the value of your digital art. And so there are exceptions to it, but like, you can start exploring what NFTs are more. There are like a lot of content on YouTube these days. This is another popular NFT called Yugo. They've been also kind of doing really well. So if you are specifically a digital artist, you can start exploring this space, and then if you wanted to experiment and start building, you can also actually start building that. this is another NFT called Crypto Barista. So it's all like how do you make coffee, right? So basically everyone takes a specific theme and then starts putting together the digital content or the, around those specific areas. Yeah, I think that's pretty much it, guys. So
Kiran, then we can take questions now.
yes, please. Yeah.
Yeah. So there's one question, what exactly is mining? And a follow-up is, when you mined the block, what did you do? Did you change the data of the block?
Sure. So what exactly is the mining? Mining is the process of doing a transaction, so on the blockchain, right? So when I did mine that particular block, so what happens is, I actually showed you this, to show like how the blockchain works. But if you're okay, let me take an example of how it happens in the real world, right? So now there are 5 blocks, okay, in a particular blockchain, okay. Now imagine if I'm actually changing the data. Okay, let me take a step back. So there are 5 blocks, okay. There is the same data on all the 5 blocks, okay. Now I'm actually coming to the block 2, and then what I'm saying is, no, I don't like this data. Let me change the data on the blockchain, and then let me do some computational stuff behind that, which is nothing but the mining, the gas fee that I'm paying to that for the particular transaction to go through. So the data on my block gets changed in the entire 5 blocks of the blockchain, right? Now the rest of the 4, they can actually review and say, okay, hey, is the data really good? Do we really need to accept the changes of this particular data, or do we have to reject the the data that has been changed on this particular blockchain, right? So what exactly happens in the blockchain is, so you need to get like a 50% vote, generally, for you to change the rather than using the word changing the data, right? Modifying the data on the blockchain. Let me put it that way. Okay. So you need to get that 51% vote. If 51% like 50, which is like if you have like 6 people, like if you have like 7 people, like 4 has to agree, right? Something yeah, 4 has to agree. So so like if the 4 people agree that okay, hey, these modifications are valid, so the data gets changed on my particular block, and the changes of the data are reflected on the other blocks as well. Okay, it's not only my block, but like the data will be reflected on the other blocks as well. Okay, uh, how it will be reflected is, okay, hey, this is the initial data. I have written, okay, hey, welcome to this webinar. Okay, then say, imagine my second statement is, welcome to the webinar, folks. Have a great day, right? So you will have the previous data, and then you will have the the modified data which has been approved on the blockchain as well. It's not that I'm going to remove that welcome to the webinar completely from the block. You are getting the point, right? I'm going to do some modification, and I'm going to say, hey, welcome to the webinar. Folks, have a great day, right? I'm just modifying that particular data, but I'm not erasing that initial data. Initial data is going to be there. Make sense now? So that is how the data works, and the data modification works in the block. So what I'm trying to say there is, it is impossible for someone, one person or two person, to completely change and modify the data on a particular blockchain. It requires like a lot of computational power. It requires a lot of consensus mechanism to accept the changes, of the data on the blockchain. Even if they accept the changes, the initial content is going to be there. Initial content is not going to go anywhere.
Thanks, Kiran. So the next question is, are emojis NFTs?
Emojis, NFT. See, NFTs are unique pieces of art, as what people say, right? Uh, how should I put it, right? So if you can create an emoji, if you're super creative, and if you can create an emoji which is not existent, in the present world, in the sense like which is not being used by anyone on the internet, okay? You create an exclusive emoji and then you say, okay, this is a piece of digital art that I have created. Then actually that could be an NFT. You can actually put it on OpenSea, mint it, like, there are like bunch of processes there. You can create your own NFT. So NFTs are unique pieces of digital art, right? So if something is not existent at this point of time, if you can create it using your creativity, anything could be an NFT.
Thanks, Kiran. So the next question is, can we upload images or PDFs or other documents on blockchain?
Yes, absolutely, yes.
Okay. And so there's one question, is it good to invest in crypto? We are not going to answer that.
No way, no, not at all. This is not at all an investing session at all.
So if there's any other question, just students enter the question into the chat section. So we have one question here, Kiran. So is hash only a 5 to 6 digit value? So I think the question is, regardless of whatever the input was, the output was a fixed length
Correct.
string, right?
Output is
So
a fixed string, correct? Yeah. In this case, so there are multiple standards for hash. So the one that I have showed, one that I have showed or that you guys have seen is SHA 2256 standard. So that is like 256 characters, 256 characters in length. It could be mix of everything. It could be mix of alphabets and numbers there.
okay, so I think that's it. Uh, we still have a few minutes left. So students, if there are any questions, just let us know in the chat section and we'll take them up. Any closing thoughts, Kiran? We can wait for the questions, but anything else from your side?
No, I would say, start exploring, guys. I think you're at the right age. And I think we are at a very, very interesting times of our, lifetimes as well, to be frank. You guys have like, lot of time, energy, scope, potential, whatnot, right? To explore this particular technology. So if we are having the conversation in 2030 or 2032, we'll be talking about very, very deeper use cases of blockchain, and blockchain will become an integral part of life, right? Don't worry about these regulations, etc., and all that stuff. Those are all part of the game. Every technology has to go through that. But start learning, right? There are a bunch of YouTube videos out there. There's like free content on the internet. Start exploring and start building. You might not understand initially, or you might understand initially, but I also would say don't give up, right? Just keep exploring. If you're not finding, go to Google or ask people. There are like a lot of Discord channels, by the way, and I think as kids you are aware of, like, I'm sure you are part of a couple of Discord channels. So the best part is you could join like multiple Discord channels of these blockchain companies. Start hearing what they are saying. Start learning about like how they are thinking, how they are building, and above all, the most important part, which I always stress is, if you're passionate of giving back, in terms of if you're passionate about working in the space, start working. Start working directly. As I said, go to Discord channels and then say, okay, hey, I would love to explore, might be this area, right? Might be marketing, might be growth, or might be, I'm good at writing, might be, let me write a research paper, or like, some sort of an article about a particular technology or coin or something else, right? Uh, you will start building, so many relationships by just working, giving back, contributing, and also at the same time, uh, I know people like, I know kids, who are in their 50s, 16s. I mean, like, in their teens, I would say, literally, and who are making loads and lots of money, in the blockchain space. Of course, everything is through, in the ethical way. I'm not saying go and invest in some coin and you become rich, not at all. But, this is a long-term game, right? You are looking at this game for 10 years, 20 years, 30 years. I always tell whoever I ask, whoever asks me, right, what is your opinion? I say that, like, hey, we are building this for our kids and grandkids, right? Don't even think about ourselves. So we're thinking, about the use cases of this technology and the revolutionary stuff that happens with this technology in 2040 and 2050, right? So imagine you guys are all like in 1990s of the internet one revolution. So you're seeing the fruits of all that, right? Smartphones, click of a button, like you can order food, you can actually order groceries, you can shop on Amazon. So the whole process took almost like what, 20, 25 years. So you are at the same critical juncture, as what internet is 1990s, Web3 is now in 2022. So look at like the longer time horizon, 20, 25 years, start building, start learning. There is a greater future ahead in terms of for everyone, for you guys especially, since you're like very young, you're passionate, uh, like a lot of interesting companies that you could build, and also at the same time you can create a lot of wealth as well. So I would say go all in. Don't shy away.
Thank you so much, Kiran. I think the last piece of advice was very relevant to all the students who have joined us today, because a lot of questions in the comment section kind of, are related to that. So thank you so much for, joining us today, since we are almost closing to the near time, to the end time.
Sure.
So
Yeah.
with this, we can wrap up today's session. Thank you again for joining us.
Yeah, thanks for the opportunity and good luck, guys. You are the future. Just go for it. Do it. Thank you. Take care.